Hi, everyone. Thank you for joining us for the next episode of our Startup Spotlight series with Howso. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand within 24 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to bring in our speakers. Gabriela, thanks for joining us today.
Hey everyone, my name is Gabriela de Queiroz, and I'm Director of AI here at Microsoft in the beautiful San Francisco, Silicon Valley. And today I'm very excited for the 6th episode, and I'll be talking to the co-founder and CTO of the AI startup, Howso. But before I kick off this conversation, I want to invite you to join me live here in the same channel bi-weekly on Thursdays. On this live stream, I'll be chatting with founders from top AI startups doing innovative work. We'll talk about their company, the product, the technology behind, use cases, customer stories, and of course, how Microsoft has been helping them in their journey. During this conversation, you can ask questions in the chat, and I'll be selecting some of them to be answered live. And before we start, let me share this amazing program that we have here at Microsoft for startups. We offer startups, no matter where you are in the journey, up to $150,000 in Azure credits that can be used in our latest products or different Gen AI models like the models from OpenAI. You also get access for free to 30 plus tools and services to help your startup grow and scale. And on top of that, you get free one-on-one sessions with Microsoft experts to work through technical and business challenges that you might have. Today, I'm very excited to be talking to Chris, co-founder and CTO of Howso. Welcome, Chris, to the show.
Thanks for having me, Gabriela.
Awesome, great. I'm so excited. I know that we are going to talk about interesting things because before we talked about some like statistics, ML, LLM, Gen AI, different topics. And of course, I've been reading about you a bunch. And I'm always interested in like when you have a founder, an AI startup founder, what is the career progression until you get to the point where like, okay, now I think I'm going to found my own company. Tell us a little bit about your progression so people can understand where you are coming from to the point that Howso was born.
Sure. Yeah. I was almost a physicist. I've always wanted to understand the why behind things and how do I build worlds and systems and simulations around all of that. And I first got started in AI, technically artificial life, back in my teens, writing little, programs to, evolve and do all sorts of various things. And I've been working in AI for pretty much since before it was cool yet again. I got into, large enterprises. I worked at Motorola when that was a big, awesome company. And I just saw I saw these problems that could be solved with more automation and digging in deeper. Went on to my PhD, again, looking at those complex systems, game theory and information theory, like the mathematics of strategy and statistics, but applied to real world problems. How do we solve hard strategy problems? How do we, for example, I did a postdoc looking at trust in the battlefield. How do you trust information from your soldiers, from allied soldiers, from sensors? How do you pull all that together, knowing that there could be subterfuge and all sorts of things going on in a robust way? And I was working in that space for a little while, and I said, because I like these deep systems, I was starting a game company at the same time, dealing with counterfactual hypotheticals. So we released Acron, my previous company, which is a real-time strategy game with multiplayer time travel. So you can lay out your strategy and say, well, what if my adversary had known this and I had known that they had known, et cetera, and resolve those types of problems. And so very quickly we're pulled into large organizations, defense, because those hard problems are everywhere. But me, as a game theorist and information theorist, I had some machine learning background. Always said, well, we've got this amazing simulation software, but it's hard to program, it's expensive to develop for, it gives great answers, but how do we get good adversary players? How do we get those deeper insights? And luck have it, I stumbled across a set of math that had solved pieces of that problem around like 2014 to 2016. And I'm like, wait, we can do ML a little differently with a deeper, richer understanding of everything. And my previous company was growing in a professional services manner, and it was okay. It was like, we're getting profitable and growing, but like we're onto something bigger here. And so I decided to take the dive into venture-backed startups, saying like, okay, let's grow what we have here. And so we've been working on the mathematics and techniques here for quite a while. It's been our secret weapon. And now, this company is, let's make it practical, usable, scalable, and available to everybody. And really, LLMs and Gen AI is that fundamental transition of now I can interact with this richer software. And so that's been my journey, always asking that why and trying to build up the systems around what I do.
Awesome. No, and I love like how your background and then the things that we are thinking about, like how you transition and made to Howso, and the things that you talk about, you are going to talk about later in this conversation. And I know that now we talk about agentic AI, and there is a lot of like buzzwords, but we still we have to say that statistics still like the foundation of like everything that we do. Even though people think like, oh no, statistics, like why should I study statistics? Why should I study information theory? Why should I study like I would say the foundation, right? So it's so important for a lot of things that we do and you do. We were having a conversation about anomaly detection. Can you go and talk a little bit about the anomaly detection and how is the company doing that in a different way, in more like context-wise?
Yeah. So if you look at the history of any sort of technology, there's always things that pull out ahead for whatever reason and things that get left behind. But oftentimes there's trade-offs among all of this. And neural networks really pulled ahead with GPUs because they had a lot of synergy there. But also there's I like to think about it as some historical baggage and statistics. Like, this is the way we've always done it. We always assume a normal distribution, and the way the statistics are taught leave out a lot of the foundations, those robust techniques that give you a better answer and really get at your assumptions. Now, I think LLMs and Gen AI have been great at shoring up and showing us a lot of that, but really they're good at doing things that have been done many times and bridging that gap between systems. So how do we do it better? And going back to the math breakthroughs that led to where we are today, like imagine that instead of thinking about some sort of machine learning model as some sort of black box or maybe some regression problem, I drew a line and said, look, I've got a model here. Instead, we ask about the data itself and the information it brings. So let me give an example. Let's say that we're measuring things about some agricultural problem, and I want to understand, maybe I'm producing wine, the acidity of some grapes. So if I take 3 grapes off of the vine, and so here's an unknown grape, the unknown acidity, and I have 3 grapes from the same vine picked in the same day, that's probably a pretty good estimate for the acidity of that grape. They're very informative. The probability of them being informative is very high. Versus if I picked a couple of apples from the trees next to the vineyard, and I said, can I use this information to predict the acidity of the grape? Probably not. Maybe there's a little information, there's a little probability, not really. But if I understand the latitude and longitude of the trees, that may be very informative to predict the street address of the farm. So everything is contextual and there's a probability of uncertainty. So if we're going to say, are these things the same? Are these measurements the same? We can measure, we can repeatedly measure, and there's some error and uncertainty there. But if we say, well, how can you predict it? What's that uncertainty? What's the average error there? There's something where we'd say, it's effectively the same. If you're asking 2 people if they're the same height, if they're within a centimeter, they're the same. So we can use it for reasoning purposes. The mathematical breakthroughs allow us to measure that probability at the data element itself, and then apply that and contextualize it just like you would Bayesian inference, but able to get cutting edge machine learning results. So if we say, what is the probability that this data record element, set of data records from a vendor, are informative to the other relevant data, we have some measure there. But if we say, if they're not informative and they're different, the probability is different, it's an anomaly. And what's really powerful about these techniques is that we're able to get, we're at least at state of the art. We're running some deeper experiments to see if we're beating the state of the art across dozens of the anomaly detection techniques. But that simple, understandable technique that brings you back to the exact data can also explain why it's anomalous. It's anomalous because all of the data is just a little bit off, or everything is spot on and within the expected uncertainties, except for this one thing or these two things. So we can give you that why and help you make the trade-offs of anomaly detection. And if it's incorrect data, we can help you remediate that. We can show you what needs to be fixed. And as many of us who work in anomaly detection know, if you have labeled anomalies that are true, this is actually anomalous, and here's why. This is not anomalous, it's false positive. You can do much better. And so we can help companies and organizations scaffold their knowledge around anomalousness. And we'll talk more about causal, but like what causes anomalies? And we can get some causal results out of that. So this is just this super capable system that just grows. But now when you use an LLM in front of it, you can rely on it. Instead of building thousands of models, one to answer, tens of thousands sometimes, one to answer every data science question you have this one set of math that gives state-of-the-art or near state-of-the-art performance on virtually any task. You can rely on it. The LLM is less likely to make mistakes. And now you can leverage and scale data science.
Yeah, and is that like, and I think that's the breakthrough. It's like before we had very specific models for specific tasks, and with LLMs, you kind of like generalize. You don't have to have one model to do this, the other model to do this other task. Like the LLM kind of like compass, like it gets everything together, and no matter what you are doing, it can take care of your task, right? So that's I would say the main breakthrough. Of course, other than there are other things, but I feel like for us, it's like, before we had like several thousands of models, and now you have this one that can do a lot of things for us.
I hadn't thought about it this way, but I feel like our system is the answer for data science to that. And that's why they work so well together, because the LLM generalizes the domain, the knowledge, but it's a little weaker at the data science. It can control that. But now when you have the data science that is just as strong and just as general on your data, now together, the whole is greater than the sum of its parts.
Yeah, no, absolutely. And I think that's a good time for us to go deeper into Howso. And then if you have some slides or something that you can share us, so we can contextualize this conversation even further and show the audience what Howso is doing, all the great stuff that you all producing, and we'll go from there.
Yeah, so this slide should be pretty familiar to a lot of us here, that we need data, we need to use data, we need to be thoughtful about how we use it, and that skill gap is growing. And like we just talked about, LLMs are good at building a model, but think about your model repositories and how many of them you have and how you're managing them. Are they up to date? What is the registry of them? What if you could have fewer of them by orders of magnitude and still have that robustness? And now, I think some of the new and powerful capabilities around using AI to develop software, like they can really amplify many developers. And now, there is also vibe coding where you use the LM to do everything. And there's some value. It's great for prototyping. But like if you want to make a production system and you're writing it in, imagine you're writing it in C using vibe coding. That is going to be rife with vulnerabilities and issues, even no matter how good the LM is, even if it doesn't matter, that's rife with issues. We're kind of doing that a little bit with data science when we're having the LLMs drive these systems. So, well, what if instead of it's driving a code written in C, what if you're using Rust and maybe even some provers and the best, most robust libraries that can do things very quickly? Now you can vibe code, or at least closer to it, with better results. And if you know what you're doing as a software engineer, you can amplify that. We're doing the same thing for data science and data insights. So one way to think about it, we've had descriptive statistics. There's many tools out there. Power BI. There's a lot of great tools. Then there's predictive. I'm going to build a model for a machine learning model, but I got to build one tool for everything. And then there's prescriptive, asking the whys and what ifs. And all of a sudden, you've got this explosion of tools and models to use. And we solve, yes, we can do some of the descriptive statistics as well, the interesting ones, but one tool, not just even one tool, one set of math, one technique can now address all of those at once. And what's really fascinating about this technique, this probability theory on the data, as I mentioned before, is that we can work with the data itself. So if you have a date time, like the date that it was measured on, and the difference between that, or a count, or a nominal, like is it class A, class B, class C, or even a small JSON blob, we can work in that data. We don't need to build a model or transform it. We can work natively within the schema, and that gives us better results and that native interpretability. And so all of these capabilities, detecting causality, which we'll talk about more in a minute, excuse me, some more deterministic results. What data led to this decision? We can do that when we're predicting those, that acidity of that grape. We can give you, here's the exact records done. And then again, there's not a model. You're not building a model for one thing. It's your data, and we try to operate as close to your data as we can in your compute. So if you've got your data in different storages, you want to run, scale something in Azure, that's easy and straightforward with us. We try to operate as close to that as possible. So when you run a query, just like you would a SQL query, that's how we think about these sort of inferences and results. We also try to play with a bit of everything, right? So people use different systems. They use different, some people use LangGraph, some people use other tools. Let's plug into everything and make those things possible. The idea here is, again, we've got an LLM in the front end. We often call it bring your own LLM, because you might have fine-tuned, you might have built it for your business practices. Maybe there's a RAG behind it, so it knows where to find all of your data. We're just plugging into that system. So let me just, take a quick second and show a quick demo, because I think that's probably what people would want to see. Let me pull over to VS Code, favorite of many people.
Yes, my favorite. Use every day with GitHub Codespaces.
Yeah. So here, first I'm going to show a small demo running on my laptop. I mean, if we want to do this, I don't know how much StreamYard. It's a little slower because we've got the video running in the background, but I'll just even kick it off in the background while we run. So this is, if it's small data, we can run anywhere. We can run in a Raspberry Pi 4 or better. Now, obviously, for big data, you need something much beefier than that. And I'll show a larger, more interactive use case in a second. So this is targeting the data scientist, or seeing like at the code level what we do, and then I'll show the LLM front end with a larger data set. So basic. Let's load the data. Now this is a shopping data set. I'm gonna scroll down here a little
and Chris, let me ask you just one question. So you have a library in Python. I see on the top. Is that it's an open source?
So we have it. We're open core. The insights package with some of this is a commercial package, but the core piece is open source. That's the Howso engine, and the Howso engine is sort of a lower level API, and the proprietary solutions that we offer are basically making it easier to consume, connect to more data sources, and scale. So if you're a data scientist, like, let me play with it a little bit on the weekend, please do. And then like, okay, now I want to use this for production, or I want it to be easier to use and scale and connect. And the APIs are narrowed and connected to the LLM in a way that it just makes it easy to use. That's the commercial part of the business.
Got it.
So this is a shopper's intention data set. Again, a small one. I'm just going to sort of show what we can do with even small data sets. Now, you see the very complicated APIs there. Basically, passing the data frame and get going. It's like the whole idea here is let's give you really good results for everything, and then allow you to drill in as needed. So it assessed, here's the high level types of the features, but behind the scenes, it knows a lot more. You can drill into the exact characteristics of them. But let's just say what's predictable in this data set. Now, here you can see all of these measures of predictability. So normally, if you're a data scientist, that means you need to build one model per feature. This is the first thing you get from our system. So what is predictable? It's very straightforward, and it is just one system. They're all using the same everything, the same math, the same nuance, the same results. So we can say, okay, what's predictable? Okay, revenue and visitor type are both pretty predictable, because if a person presses the button in the shopping cart and clicks buy, I can predict some aspects of that pretty high. But also it's a bit of an imbalanced data set versus predicting the region that someone's in. I just don't quite have the data in the data set to get a high accuracy on that. And here I'm just looking at accuracy, but obviously all those other measures are available. So what's important for predicting whether a online shopper will make a purchase? Okay, so let's look ahead at the data. Just particularly there, we can, now people are used to feature importance. Let me talk to that a little bit. So SHAP, which is kind of was a gold standard. It's still a standard, but the gold is sort of lackluster now, is great because it tells you how much each piece is contributing to the prediction of the model. The problem with SHAP is a couplefold. One is it is often expensive to compute, not always, but the other one is that there's inductive biases in there. If your model had optimized out one feature or another, it'll say feature A is exactly the cause, or the reason, the important feature, but B was just as important, and the model optimized it out. You don't know that. So whenever you're using SHAP, you've got to be careful to say, like, is that actually what's going on in my data, or is that this approximation of the model? What we're able to do is, because your data is in a database effectively, we can drop features. We can do what SHAP intends and tell you, the actual attribution down to those individual elements. Additionally, we have something that we call accuracy contributions. So this would be the SHAP, and accuracy contributions are more how are these features driving the uncertainty, the predictability? Why does that matter? Imagine I have a lever that controls a gate, a sluice gate, like for water flow, right? So I've got a stream going, and I can pull the lever, open up some more water, and it'll flow into there. Causality in a lot of the causal work shows that there's changes in the uncertainty in both parts of the system. There's rises and lowers in the water flow. I can predict it, but there might be waves. There might have been a rainstorm upstream. It raises a little bit. So there's some uncertainty there, and there's some uncertainty in predicting the lever. But when I pull the lever, that changes the uncertainty in the water directly. I can see that the lever changes the predictability in the water more than the water change predicts the change in the lever. That asymmetry is necessary for causality. So the vertical axis is really grounding in things known as causal entropy or transfer entropy. This isn't the time series data set, but if you apply it to time series, it is. So now we're able to say causal results and predictive results and show you. So here, for predicting revenue, page values, that makes a lot of sense because page values are computed from revenue. But I can see that the month seems to also be pretty important for this result as well. So what causes? Well, visitor type seems to be by far the most important. And by the way, we see this a lot in some of our customers' data sets where there is one driver of most things. So you say, okay, we know that, but let's drill deeper. And the ability to condition is where a lot of the power comes. So we can say that's what the revenue column means. You can see what actually led to that. We could say, it's so the revenue and page value, we know that linkage. That's from the math. But the visitor type, okay, that seems to drive the month. So there's some weird relationship behind there. Maybe there's another driver that is causal to both of those. The exit rate. So certain visitors just sort of leave. They come and go very quickly. Maybe there's some bots. Maybe there's something to drill in there. And again, these are where the revenue is true. So what we want to improve our revenue overall. So we're going to look at the ones where they leave. They don't actually buy anything. And now we see, like, okay, the operating system and the browser seem to cause how long they look at things. Maybe there's a commonality there. Maybe people who own these types of products tend to look at these types of products as well. Let's drill into that. These are the sorts of questions and conditional questions that we can answer very quickly. As you can see, whatever condition you want to pass in there, it just works. It's very straightforward. So what does that look like when you put an LLM in front of it? Now you can ask even richer questions because it doesn't have to build thousands or tens of thousands of models. It can just ask the questions. So let me share back to the slideshow. And the reason why I'm going to show this in the slide is because this one is if I recall, a bit larger of a data set, and it wouldn't be as good for real time. But so this is, the font is a little bit small here, but so in this case, we're looking at a TV sales in Miami, Florida. Like, what do we do for that? And so my question is, what do I do? What do I do to improve TV sales? Like, you can ask it those sorts of generic questions. Now the LM will say, these are the sorts of things I might need to know. And behind the scenes, you don't see it in this particular view, the LM will be making hypotheses, reasoning, but then for every reason, we've instructed it via prompts to say, don't just guess on what you've been trained on. Look at the data. Ask this tool-based API the questions so it can construct all of them. So as you go through a bit, it can give you the causal, what is causing what here, give you summaries of it, and even so at the end, it did all this work. and said, here's what you need to do. Let's see, it's the slider. Go to this one right here. So it's showing you, the customer loyalty level has causal connections to purchasing patterns. Okay, that's useful. Store location influences inventory levels. Okay, I knew that, but like maybe I should drill into that further. It starts to show you all of these things which an LLM could show you, except if you ask why, or you say, this is a $30 million issue for us. I don't want to just trust the LM. I want to validate. I want to have a data scientist spend 2 days. This is an important decision, important implication. Here, let me send this bundle of stuff to the data scientist, the chat, but not just the chat, the reasoning, and then every artifact pointing back to your data sources, the inferences. If they want to say, well, this particular inference was very important, let me see how you did that. They can inspect and dive as deep as they would like, down to the exact data that was used. And they have that level of attribution all the way back. So if you're just asking a quick question, how do I reduce customer churn? It'll give you an answer that is well grounded. And if you're like, let me just spot check, like you might with an LLM to say, a RAG LLM, you might say, okay, that looks good, but it's important. Let me make sure. And you click on a few of the documents and say, yep, okay, this is good. You can now do the same thing with data and data science.
Oh, wow. And I'm a data scientist. So like, this is like a wow for me, because it would take me like forever, like several weeks to do this kind of like analysis. And I probably would go back and forth with my stakeholders to talk about like what I'm seeing and then discuss with them. So it would be a lot of like back and forth, where like now what you're showing, it's like I have a great insight right away. I can take decisions, make decisions, take actions in a more fast and reliable way. And do you have any like metrics, like how much do you save in terms of like time, maybe?
Yeah, it looks a lot like what we're starting to see for programmers, and that's why I used that analogy before. Where some of our data scientists internally, when we're helping customers solve problems, they might say, "Oh, hey, look, in an afternoon, I came up with all these great answers," and it might have been, like you said, a week, maybe 2 weeks of back and forth. So we're seeing in some cases those orders of magnitude savings. Now, again, if you want to validate, okay, it's easy to validate. So even in that validation step and the evidence, we save there as well. I think we're still early figuring it out, but the further we move along, the more it seems like the return is there.
Right.
Like
No, exactly. And then like, especially like for companies that don't have the ability to scale those teams, they can use Howso to help them as well. So they don't have to scale the teams as well. And like there is a time, there is a scalability on the data science side. What about like the data engineering? Because I know that you have the other piece on the data engineering as well.
Yeah. So one of the also beautiful things that happens with these probability techniques is, again, we can operate in the domain of the data schema itself. We don't have to do all the types of encodings. And if your data is a little messy, that's actually okay. If you've got missing data in there, that's great. These probabilistic techniques can say, does the missing data mean anything? People who make between 100 to 150K a year who don't answer question 12 also seem to not answer question 13 and have this other property. All of that just comes out. So we actually tell our customers who use the lower levels, don't do as much data engineering as you would normally like. That's where the benefit from the LLM comes in, is that it doesn't have to do as much work. Now, of course, the LLM may need to choose a particular view of relational data or find a schema that matches the JSON. But these problems, that data engineering gap becomes significantly less.
Yeah. And then you were saying like that no matter where you are, you go and plug in Howso on top of that. So you don't have to be moving data to different places. And I feel like there is a lot of like, of course, security stuff. We are always worried about privacy, security. So that's not a problem for enterprises and companies should be using Howso, because you go where the data is.
Right. And I would say for many of our customers, there's no way I could even access this data schemas that they're using. Like we're that far removed. Like there's no access whatsoever. We just help them, work through their initial proof of concepts, and many of them are just off and running. Once they get that first taste of the system, they're like, oh, we can apply it here.
Yeah, no, absolutely. And then other questions that I have is like, do you have any like customer stories that you could share with us of like, problems that they were having. And then by the time they were working with you, they were able to get ROI and other great numbers.
So let me share one. I can't name the customer, but it's a really fun one. They're a major international airline that is they do very well with safety and quality. They're a very quality brand. They have an amazing data science team. It's large. They're very capable. But the problem that they're facing is the biggest one is maintenance. Cost of labor is going up in many different markets around the world. The pieces, do we have what we need? Did we replace this part too early? Did we do it too late? What are the risks associated with replacing it too late? These are very valuable, expensive, important questions for the whole business. And there are some pieces, some components that, think about an aircraft. Think about all the telemetry, all that data for just a single motor. You might have many, many features. There's so much data on these things. How do you figure out whether something is about to go, whether you should replace it now, whether it's a high risk, a low risk? And they were struggling because despite the size of their team, they couldn't build enough models to answer these questions. And also, before these probabilistic techniques, many of the causal mechanisms to determine what's causation in there they're hard to use. Like many of them, you have to bring in a subject matter expert, have that person lay out what they think it is. Then you run some hypotheses and they're like, oh, this matches, this doesn't match. And then the powerful techniques only work in bivariate or maybe like 3 variables, small number of variables. So it's this iterated, expensive, costly human back and forth for all the causal mechanisms. What we're able to do is basically take in a few of their components, plug that into our system, and in a overnight run or a couple back and forths to ask these questions, we're able to say, before this component failed, now this particular component it's important, there's a lot of redundancy, but they'd like to not have it fail because when one of them fails, it adds extra wear and tear to the others. There's a risk associated with the flight. There's all these things. Did you notice that the predictability of these features, like the voltage on these motors, the predictability changes? The uncertainty around it changes. And that is what is driving these anomalies, which end up driving that failure. And we can show that. So they can say, oh, when this predictability goes out here, we can measure the envelope of uncertainty. So based on this part, we're okay because it's an inconvenience to the customer and a wear and tear on some redundant parts. We're okay with 1 in 10,000 or 1 in 100,000 probability of failure. But this other part over here, no. That's got to be like 1 in a billion or on up. So they can now bring in their risk reward questions and trade-offs and what their tolerance is and the cost, put all this together, understand what's going on to a much better degree because, V equals I over R, like there's basic equations for electrics. I can predict that. But when there's a short circuit, when there's a wire, when there's something that's fraying or something overheating, those characteristics can literally go nonlinear. So looking at the data and what is driving those, understanding what those failures are and getting to the right level of predictive maintenance, replacing the parts that they wish they would have and waiting a little bit on the ones that they didn't need to. So that's one of my favorite use cases because it is both delivering value, notable value, and improving the safety of our travel.
Amazing. And is there any industry or vertical that Howso works more often? Like if it's bank, airline, or any other verticals that you see the need in the...
Yeah. So finance is, we've been working in finance a bit, merchant services, banks, et cetera, because they all have these problems. You think about any sort of risk reward trade-off, customers, like how do I leverage and scale my data scientists in my data science community? Maybe I don't have many. Like we've talked to some surprisingly large, let's just say companies in the financial space where I would have expected them to have a bigger data science team, but now with our software, they can. Without having to you don't have to hire 20 people. You can hire a couple and now get all those benefits. We're seeing significant interest quickly in the consumer goods, especially around where do I put my inventory? Here's a big event. The Super Bowl happened. Did I move enough of these color and these logo things in this place and this place? For example, you might say somebody's favorite sports team, you might think, oh, well, the best predictor might be their zip code, right? What's the closest team? But actually, that's often true, but oftentimes it's the zip code where they spent some of their formative years of their life. So what other measurements can you get from that to inform and sort of predict different, demographic shifts to forecast and predict those where things are going to be? And then also, because we can condition very easily, you can put if you want to go to the lower level API, you can put code in the middle of the inference in a forecast the same way in Excel you can put code in the middle of your data. So you could say, well, what if my rate of return on this product, or the change in price decreases with this function, and just plop that in there and now do 30 forecasts to understand how the uncertainty is characterized given this new piece in there. And it really makes data science and the data programmable. So we're able to give very interesting hypotheticals, counterfactuals around all these forecasts, and then say, okay, I think this is pretty cool, this hypothetical. Oh, but the uncertainty got really big because I don't have much data. So I can't really believe it too much, but if I collect data like this, that'll be my answer. So then you have those business discussions of, do we take a risk with this or not, and make those informed decisions? Or if you have enough data, here looks like the causal drivers. Now, going back to my lever analogy, if I'm pulling a lever and it's increasing or reducing the water, well, it's not just the lever causing the water. There's a gate that's raising and lowering. Maybe there's a pulley system. So there might be other causal mechanisms in between. But if you know the start and the end, you can now say, well, what other pieces of data can we use to understand the causal chain? And that's where LLMs come in handy, because you're like, well, here I'm seeing there's a causal driver between A and B. And the LLM says, well, in this field, and based on this other trend, I can see here's 5 examples of what other causal mechanisms will be. And now you've got ideas of what data you can either collect or buy to get better results and understand. Conversely, it can say, this data that you paid a lot of money for, it's not helping with your prediction. Maybe you should stop paying for that data.
That's a great point, because we always spend a lot of money buying startups. We buy data, or we don't have enough data, and even like big companies as well. And Chris, I'm interested, like with Howso, if you think about the trajectory of the company, can you think about some of the challenges that you went through as a co-founder, CTO, and how how did you overcome some of them? Because we have a lot of founders in the audience, and that's a question. We have a lot of questions of I have so many challenges, I don't know what to do. And can you share with the audience 1 or 2 key challenges that you went through?
I would say if you don't have major challenges, you are more lucky than anyone I've ever met in a startup. So I'd say some of the challenges that we've run into is one of my challenges is good enough. Like, I put this data in the system, I got a linear regression. Look, it's got these wide error bars. Linear regression has been done for 100 and plus years. Is that good enough? Well, my question back to you is it good enough? And so I feel like, the good enough has always been one of our barriers, where, okay, your technique's very powerful and interesting, but I've kind of got something, how do we provide enough value, enough scale to make you think, okay, this reliable system I have that doesn't scale or only answers 3 questions, let's consider, so we've changed our way of thinking about it. Is let's not replace, let's augment and scale and those systems, plug them into ours. So for us, I'd say that's been one of the drivers of making sure that we're communicating, and we're, even to this day, we're still working on how do we communicate these ideas around probability theory and inferencing on your data to people who are not used to these things. Like, I talk to people on occasion that think, well, it's impossible to know what data was used to make a prediction. And I'm like, only if you're thinking in black box techniques. But no, here's some basic older techniques that give you okay results. And here's the latest cutting edge ones that give you good results, and you have that attribution. So I think there's a little bit of education around that too. So for us, it's working on that messaging. So I'd say that's one bend of being, you want to be different, but if you're too different, that's hard too. So I'd say one of our biggest lines to straddle of how do we solve that. Another one, and I'd say there's 3 ones that pop up to me. Another one is people always want scale. So for example, like, hey, we solve these problems. You got 1 billion records, sure, no big deal, like run that. But now we've got this other capability that we prototyped, and it looks really good in small data. We've experimented in data science. And now one of our customers says, oh, that is exactly what we're needing. And we're like, oh, we haven't run that one at scale yet, and we haven't scaled up that algorithm. So suddenly, we're scrambling and figuring out, okay, how do we algorithmically come up with really close approximations or algorithms to make this piece scale too, as we get scalability across all of our, every workflow, every possible question you could possibly ask it. And like one of our answers to that is leveraging some of our technology in itself. And it's not quite, drinking your own champagne is often the new metaphor for that, but close, where let's use the probability space in the science to reduce the data. You can always take a random subset of your data and get a rough idea, but some of the techniques that we've developed happen to have an amplification flywheel where we can find what subset of data gives you 98% of the signal. So it's not a random subsample, but it's a thoughtful subsample. So take your data, compress it into a problem that we've already solved, and now you can run that fast and interactively in a laptop. So there's a few cases where we've taken those large data sets, which might have taken minutes or hours or even days or compute days to answer those questions. Sure, if you spin up an auto scale, you can maybe get it in 20 minutes, but you're going to spend a bit of compute. But make those, do some of the pre-compute, spend some of that, and now iterate quickly on these questions. And now once you've got it, you're like, okay, I think I've got the answer. Now let's run it and let's actually scale up the compute in the real thing because I really need that exact answer. So it's really helping you control where you and your algorithms spend their time. So it's, for us, it's kind of leaning into some of our own technology and techniques to solve some of the scale problems. But also it's challenging because what do you prioritize? Customer A asks for this new capability, which you've almost got ready. Customer B is asking for this capability, which you have, but it doesn't quite scale to their needs yet. And it's constantly always listening very close to your customer and customers and figuring out where, this is the most bang for the buck that will help everybody. And then I think the last one, which is, I'd say a problem in the earlier days, but is becoming less of a problem now, is interoperability. I think that LLMs and some of the data standards that we have today have just been a boon. Like if we were to try to do this 8 years ago with this level of interoperability, I'd be like, all right, what are the 3 things that we're going to build for first? What are the 3 data sources? But now that problem is, I guess by waiting a little bit, that problem is getting easier and leveraging the ecosystem and partners like Microsoft to basically give us these interfaces, and then the LLMs to be able to glue this stuff together concretely, quickly, and easily.
Great. And you just gave me the segue for the next one, which is the Microsoft partnership. You are part of a program from Microsoft, and I'm always curious to learn and listen to what are the benefits of being a partner with Microsoft. I know that go-to-market is a big one. You are on the Azure marketplace. There are a lot of exposure opportunities, but tell me a little bit about how this all came together and how it helped the company grow and scale.
Yeah, I don't recall exactly who made. Actually, I know. I think you guys reached out to us for one of the relationships, and it has just been fantastic. And I think the secret weapon that Microsoft has here is the amount of collaboration and how people are incentivized to collaborate. It makes everything great. There are some partnership programs and some companies who are like, well, let's use you for now while we build out this competing things. It's not cooperative, but with Microsoft, it really is. It's, hey, we really want to do the best for our customers. We have a lot of capabilities, but you solve this one thing. Let's bring you in here, and let's also share our resources here. And those sorts of conversations with go-to-market, understanding customers, understanding opportunities, and just the depth of capability and knowledge and experience that Microsoft has is just invaluable. It is amazing. So I can't speak. That is by far the best part. But I also can't complain about the help with cloud compute, domain expertise. Like, oh hey, we're integrating with this thing, this new capability that you have. It's still early. The documentation is still growing. Can you help us? And we get connected with an expert who's like, oh yeah, that's coming soon. Here's the little thing that you need. Put this. Copy paste this configuration in and it'll work better. Like that sort of rapid iteration or rapid feedback has just been great.
Yeah, and I tell people it's more than the credits. There is a lot of other things that come with the Microsoft partnership for startups, especially because you don't have all the resources. So you need to be partnering with companies so you can scale and get to clients and get exposure that you would never get otherwise. And one of the things that you mentioned, it's about scalability. And I feel like that's the pain for all the startup founders. It's like sometimes it's working something that I'm building is working with like a small subset or with my prototype. But then when I work with a client, and especially when they want to scale, is when things go wrong. So I see a lot of like, especially right now, a lot of like startups like trying to bridge that gap from like what I have here is working well. Maybe I have some benchmarks, but then when I work with clients, it's not working well. So that's, I would say, it's one of the main pain points that startups have. It's like, how do you scale? Also, like the other pieces around, which I would love to hear your take, is like when you were thinking about, doing what you were doing now. Did you know that there was a need for this type of product, or it was like a coincidence? You were just like developing, and then you were like, oh yeah, there is a space for us here, and then let's go for this direction. What was the take for for the company and
Yeah.
yourself?
So let's see. So let me go backwards or like let me pop the first one off the stack. So for us, the tech here grew out of an immediate need for us to solve problems in the simulation space. To solve good reinforcement learning players in very hard strategy problems with large amounts of ambiguity. And that problem space is very, very important, and I hope it continues to grow, but it was not quite growing fast enough. And so for us, we said, okay, we've got a better mousetrap. And what other areas, who all else has problems related to it? And so I think that's been our journey. So we knew it solved problems that people had, but the problem was that we had to uncover, and I think we finally cracked that nut, and we're is who finds it valuable and how can they use it the best? Like, some people are like, okay, here's a problem that we know exists, but how do you solve it? Right? There's people who have a solution in search of a problem. And I feel like we were a little bit of a hybrid where we had a solution in search of real problems, but not exactly the ones that were the highest value, but real problems. And how do we connect the dots? And I feel like some of the capabilities with LLMs, and also, the knowledge of an LLM hallucinates, was actually beneficial to us because it widened the appreciability of uncertainty and how it plays into all of your decisions. And I think one area that Microsoft has helped us a bit on this is, as you said, as a small company, what do I prioritize? We've got small sales staff, and they're only talking to a few people, versus Microsoft has a very large sales staff. They can say, let me tell you what the top 300 companies are experiencing on this, and aggregate that information. That is so valuable and informative, where that can help us figure out where we prioritize, which aspects of scale do we worry about, which features are most important. And so I'd say that conduit of information has also been very valuable.
And another interesting thing that I see is you have a lot of patents, which is not very common to see, I would say, in a AI startup, because you don't have time. Like patent, it takes a while for you to go and file and go through all the process. What are the patents about? Like, it's like the models behind the technology.
Yeah. So when I first said in the previous company, like, wait, I think we're onto something. I think there's, in that, like, we've got a problem, we've got a solution to a problem that exists. How do we apply this to bigger and more problems? My friend Mike Capps, who'd formerly run Epic Games, kicked off Fortnite and retired. I invited him, like, hey, like, I know that I do a lot of defense work, and I don't really know exactly what I do, but I think I'm onto something. Give me some advice. And he's like, "Whoa, like, this is something that I might want to help you out with. Invest in, like, understandable AI." And a friend of his, Mike Meehan, who's had a long affiliation with our company, was formerly, I'll get it not exactly right, but he headed a lot of IP and legal at Google Geo, and then he was head of IP at Uber. And he's like, whoa, when he did some of the initial tech due diligence for some of the early seed stage investment, he's like, this feels like neural networks 15 years ago. We've got to patent this. And I'd say, so it's been a super valuable having somebody with that level of knowledge who's managed vast patent portfolios say, this is exactly what you need to do to protect yourself. And I'd say it's been very helpful for us both in fundraise, but also leveraging the open source. We can use open source. We know we've got coverage and protection and still provide value in many areas. being able to deliver and say, actually, we do provide value over here, even for the open source pieces, with our other capabilities in the patent portfolio and the patent protection. So it's been, I will say it's very unusual, the size of our patent portfolio, but also, frankly, because this was such it's one of those things that is simultaneously novel and obvious in hindsight, but it wasn't at the time, these techniques, just how they folded together. It was, so it was, let's say, easy in patent sense to get very strong patents that cover very big pieces of this.
Awesome. And you mentioned understandable AI, and we often talk about explainable AI. Is there any difference between these two terms, or like they are the same thing?
Yeah, so this is having been involved in technology for a while. There's always the phrase that the buzzword that becomes watered down, and we see this in all sorts of domains, right? Like it used to be explainability meant a certain thing, and interpretability meant a richer understanding, and there was an overlap, but there was a distinction. And then interpretability started to become overused, and now explainability kind of means I have an explanation. Let me give a fun anecdote from a publication in the 1970s that I really love around this. The group was looking at violating social norms. Like, how do we violate social norms and still get away with it? And back in the day, there was Xerox machines, big copy machines, and long lines of people waiting to print out copies of their slides before we had slides for going into their meetings. And they said, well, can I cut ahead in line here? And most people said no, like only like 30-40% people would let people cut ahead in line. But if they say, excuse me, I'm running late to a very important meeting, can I cut ahead and make copies? People said, oh, okay. Like 94% of people would be nice and do that. So they said, how egregious can we be while still, getting ahead in line? They said, can I cut ahead? I need to make copies urgently. Or like, hello, can I cut ahead because I need to make copies? And something like 92% of people would let them cut ahead, all because of that word, because. It's a short circuit in our minds. And so for me as a scientist and building out these scientific domains and like, let's do better data science, when we have these machines that are very good at giving us a because, whether it's right or wrong, we sort of shut down and say, okay, it must be right. And so we're using understandable because we're like, we want to show you the same way. If you took an exam in a civil engineering course in undergrad, and you had to show every step of your work with units of measurement, and if you get a few of those wrong, you might get a lower grade, even if you got the right answer, because if you're going to build a bridge, you've got to communicate that to somebody else. Sure, if you're making a prediction about whether to have 10 or versus 8 of this in some small real-tail problem, then nobody cares. But if you're making life or death situations, we better hold ourselves the same standard as civil engineering and those sorts of things in data science. So let's do that. So for us, that understandability is literally that level. Let's get, if you need to, if this is that decision, let's make sure you can go down to that level of math, having the same quality of results as you'd expect from machine learning, but that level of transparency.
Awesome. And we got a great question on the chat from Harika asking, what strategies can be employed to detect and reduce hallucinations in LLM generated text?
Yeah, so I think that the biggest one for me is, again, going back to the data. So I think that many of these techniques we're using, let's just say RAG-like systems. I know there's a whole zoo of different types of RAG, but like let's really get it back to that data that is using and make sure we build that feedback loop in. So you may look up things that we're using the context window. Let's double check them, and let's provide every opportunity for the user to recognize that. But then I think we also need to start thinking about that uncertainty around these predictions. So we're beginning to see some of that in LLMs, but very confidently we'll say, here's your answer, or some of the more advanced ones. And I feel like actually Microsoft Phi does a pretty good job in some of this, the Phi-4 model, saying like, well, I think, and contextualizing it in the research. So I think moving more in those directions, but then also giving people that ability to introspect and to check and validate. Think Wikipedia, I think, is a great example where you can read it. It's pretty reliable. But if you're like, I really need to know the answer to this, go to the citation, double check, read that, and just make sure that we keep that transparency. And I think that iterative process will keep pushing the whole ecosystem closer and closer to higher reliability.
Awesome. Thank you. We have a few more minutes left, but I want to make sure that I touch on 3 more points. One is, if anyone today that is watching this want to go and try Howso, I know that you all have a playground that I can go and play around. Is that like the first place that I can go to test
Yeah, we've got a playground. I would say, like, even just going into, like, if you like to code, or if you have an LLM that can help you code, just dive in and start using our packages and play around and see the sorts of results you can get out. Some of our more advanced things, like some of the causal results and scalability, that's all like that. That's the commercial side of the business. But yeah, absolutely. And we are working on a more. We've got a couple technical reports out there to show how things work, but we've got a new one that we're working on to really bring it all together. And I will say that I've been on this mathematical journey, across a couple companies for a while, but the biggest breakthrough has only been in the last 3-4 months, and that we're working on preparing for wider dissemination. So that part is coming, but all the pieces are there out there.
Oh, that's cool. So like I see on the GitHub that you have like some you have a repo that you can do. You have like sample notebooks.
Yeah, we call them recipes.
Okay.
Yeah,
The recipes. Yes, I'm
Yeah.
going to share that on the chat so people can go and play around. I'll see if I can make a PR to this one so people can use GitHub code spaces.
Sure.
Instead of like running on the dev container, they can also run on the GitHub code spaces.
Yeah.
So that's the beauty of like open source. We can all contribute and open PRs. And I see on the website that you are hiring, and I'm very happy to see that one of the positions that you are hiring for is field data scientist, but you also have backend software engineer and then software engineer or more like on the performance algorithm numerical computing.
Yes.
Yeah, and the field data scientist, again, it's a lot of things that you are mentioning about. I would say as a data scientist, that would be one of the dream jobs to work for Howso. Great. I'm looking at the responsibility. Sorry, I'm just like getting geeky and and happy here on reading the description. And how big is the company right now? How many people are in the company, and what is the distribution?
We're very engineering heavy. We're about 20. And
wow.
we're in those points of scale where, like, we're we need to grow the team soon, but like things are looking like they're starting to pop. So I feel like we're going through the, whenever we get those S curves, we're starting to go up like that in terms of our window. So very likely we'll be hiring a bit more probably come this fall. Fingers crossed.
Yes, awesome, great. Chris, any final thoughts? Anything that you want to share with the audience before we go and wrap up?
Yeah. So I guess my big call to action here is, I said I was almost a physicist. Like, I always want to know the why. Is that, all of these machine learning capabilities give us immense power, but with immense power becomes immense responsibility. If we don't ask the why, and we don't build systems that are robust, that are resilient, that can give us those reasons, and we can trace it back and develop the science, we're sort of developing intellectual debt the same way we would develop technical debt. And so let's all be scientifically minded. Let's not just say, well, this technique was best practice circa 10 years ago, and keep using that. Let's keep asking the why and build up all these techniques so that everyone can understand. Blaise Pascal was trying to solve the problem of gambling. Before he existed, you'd roll dice and nobody had any idea how to price gambling. So he was trying to solve that problem and bequeathed on the world the idea of probability theory, and began that whole trajectory. So now I can say to anyone in the world who's had a certain level of education, there's a 50-50 chance of this occurring. We all understand that. That's part of the operating system of our society, and all the world societies, this level of understanding. And I think we can continue to do that with machine learning. So machine learning has pushed up our capabilities. Let's keep the science and the understanding up there with it. And so that's my call to everybody in the greater scientific community and engineering and deployment communities to let's not lose sight of that, so we can all do better together.
Awesome. Thank you so much, Chris, for being here today. Excited to see what Howso will be doing in the future and following the journey. Also, like I will try out the playground, the recipes, and so on. Thank you so much. Pleasure having you here today.
Yeah, my pleasure. Thanks for having me, Gabriela.
Thank you. And for you today, thank you so much for joining. And as a reminder, every other Thursday, 9 a.m., the same channel, we have other AI startup founders joining me, talking about their product, doing a demo, talking about Microsoft partnership. If you have any startup and you would like to be on the show, please get in touch with me and we'll see if you can come and talk to me next time. See you in 2 weeks. Bye.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.